Hi. Last three videos we have discussed different structures, right, in order to realize the system. Especially in our DTSP, we are going to discuss system as a filter. Okay, so we have discussed direct form 1, 2, and cascade. The last structure is parallel structure. Um, This structure is also very easy. Okay, parallel forum structure. Okay, a parallel forum realization of an infinite impulse response system can be obtained by performing a partial expansion of h of z is equal to c plus summation k is equal to 1 to n c subscript k divided by 1 minus p subscript k z inverse. Here pk is pole. Okay, pk is pole. Okay, so just here we are substituting the value of k from 1 to n. So then we are describing this equation by substituting the value of k is equal to 1 from k is equal to 1 to n. So here h of z is equal to c plus. So here the first value is 1. So c subscript 1, see here this equation 1 minus, here I am replacing the k value as a 1, p subscript 1 z inverse plus c subscript 2 divided by 1 minus p subscript 2 z to the power of inverse. Okay, and so on. The final value of k is capital N, c subscript n divided by 1 minus p subscript n z inverse. Okay, so these are transfer function, right, are h1 of z. Okay, these are the individual transfer function. So h of z is equal to c plus h1 of z plus h2 of z plus h subscript n of z. So here I need to find out the output, right? You know that the transfer function h of z is the ratio of output divided by input, right? So here you are multiplying this input function with this equation. Okay, so y of z is equal to c x of z plus h1 of z into x of z plus h2 of z into x of z. See here, this is the equation, plus h subscript n of z into x of z. By using this equation, we are going to draw the parallel forum structure, right? So here c is a constant, is multiplied with the input function x of z, right? So here c is a constant, is multiplied with x of n. This is a constant multiplier. If you are writing like this, it is a constant multiplier. So which is added with the second term of the above equation. The second term is h subscript 1 of z into x of z, right? X of n, so is multiplied with h1 of z, right? So these two terms are added with this symbol plus, okay, or component plus adder component. The third term is h2 of z into x of z. So x of n is multiplied with h2 of z. So this term is added with these two terms. It goes like this. The final term is x of n is multiplied with h subscript of n of z is added with the other terms. The final output is y of n. This is the cascade form of, parallel form of structure. So here in the cascade form we will represent the individual transfer function using a dot form. Keep it this thing in your mind. Okay, h1 of z dot h row of z. But in the parallel form structure, we are representing using a plus symbol. Okay, in cascade we are using dot. In the parallel form structure, we are representing the individual transfer function with the plus. We are adding all the transfer function, then we will get the final total transfer function, right? In the cascaded form, we are replacing the transfer function, right? In the structure, we are replacing one after the another, but here we are replacing one below the another, this one, right? So h2 of z is placed under the h1 of z. This is the parallel form of structure. So we will discuss one problem in the next video. Thank you very much. I hope you will understand parallel form structure. Okay. We'll see in the next video uh, one problem related to cascade, sorry, parallel structure. Thank you.